Stowage of cargo. Stowage, the arranging and packing of cargo in a vessel for shipment. The shipper or his agent sometimes gives specific instruction concerning the way in which cargo is to be stowed. For example, a shipper may require that his shipment be placed below deck if it may be damaged by exposure to the element above deck, or amidship if it may be damaged by the greater movement of the vessel in fore and aft section. First, exporter must be aware of principle of cargo stowage. Next, the prime consideration is the safety of the transport unit employed. Last, stowage of cargo must comply to the general safety of the transport so it would not danger others. Stowage plan. A plan showing the distribution of all cargo parcels stored on board of a vessel for a voyage. Each entry on the plan details the quantity, weight, and port of discharge. A plan presenting the quantities and the description of the various grades carried in the ship cargo tank after the loading is complete. Stowage method for break bulk cargo. Bag cargo. Subject to damage by water, sweat, and leakage, it is ideal for a wide variety of products such as flour, cement, and fertilizer. It can be stuck on pallet to facilitate. Bale. Canvas cover often cross-looped by metal or rope binding, more suitable for paper, wool, cotton, and carpet, not recommended for high-value commodities, cheap and effective form of packaging. Cartons, constructed of cardboard, strawboard, or fiberboard, inexpensive, expandable, aid of marketing, handling, and stowage, ideal for containerization and palletized consignment. Crates or skeleton cases, used both in air and sea transport, ideal for goods such as machinery and domestic appliance, a wooden construction. Barrels, conveyance of liquid or greasy cargoes, possibility of leakage if the unit is not properly sealed, or possibility of the drum becoming rusty. Acid can also be carried in plastic drum or bottles. Aluminium, globally used and constructed of aluminium, lightweight, and both can be stuck or interstuck.
Hi and Assalamualaikum, I am Azrin Akila binti Azman and I'm going to present about marking of cargo. The marking of the cargo is considered an integral part of the transportation process. The purpose of marking is to describe the cargoes to be shipped to the fullest extent, which means that depending on the type of cargo, the packaging is to be marked with the below stated handling marks, basic marks, additional marks, and marks of informatory character. Goals of cargo marking: to give information about the contents of the package, minimizing risk of cargo damage. Proper marking speeds up delivery of the goods to their destination. Recommendations for careful handling during loading, unloading, unpacking, transport, and storage. Complete marking must comprise the following three parts, that is, shipping mark, information mark, and lastly handling instructions or handling marks. Shipping mark consists of identification mark, for example, initial letters of receiver or shipper or of receiver's company name. And the next one is identification number, for example, receiver's order number, total number of items in the complete consignment, and number of the package in the consignment, and lastly, place and port of destination. And the second one is information mark. Information mark consists of country of origin, that is, the country of origin must be stated in accordance with the provisions of the particular countries. Statement of the country of origin is often mandatory. In some cases, it is not desired and, if contractually agreed, may even have to be omitted. Failure to comply with such agreement entails a risk of blacklisting. And the next one is indication of weight of package. From a gross weight of 1000 kg, packages must be marked with details of weight. With regard to ease of transport, handling and storage, the relevant standards also recommend indicating weight from a lower threshold. Lastly, dimensions of packages. Standards specify that dimensions be stated in centimeters. Handling instructions or handling marks help to ensure that greater care is taken with cargo handling. It must be possible to tell whether the package is sensitive to heat or moisture, whether it is at risk of breakage, whether top and bottom are, and where the center of gravity is located. And lastly, where loading tackle may be slung. Symbols for package handling instructions are internationally standardized in International Organization for Standardization and the German Institute for Standardization. The symbols must never be omitted as they are self-explanatory and so overcome language problems in the international transport operations. Now I am going to explain a few of the symbols. The first symbol that looks like a glass is designed to be fragile and handled with care. The symbol should be applied to easily broken cargoes. Cargoes marked with this symbol should be handled carefully and should never be tipped or over or slung. And the next symbol is designed to use no hooks. Any other kind of point load should also be avoided with cargoes marked with this symbol. The symbol does not automatically prohibit the use of the plate hooks used for handling bagged cargo. The first symbol that is designated as top, the package must always be transported, handled and stored in such a way that the arrows always point upwards. Rolling, swinging, severe tipping or tumbling or other such handling must be avoided. The cargo need not, however, be stored on top. Next symbol is designated as clamp here, stating that the package may be clamped at the indicated point is logically equivalent to a prohibition of clamping anywhere else. These are the examples of symbols of handling marks. These are the examples of shipping mark guidelines. There are a few key shipping marks related rules that shipping companies need to follow, and these include the port and identification marks that indicate destination and transfer points should be applied by stencil with waterproof ink in a large clear font on 3 sides of the package. Next, coded marks rather than trade names should be present in the shipping mark in order to help ensure that the handlers are less aware of the contents and therefore that the goods are less subject to the theft. The codes should be changed from time to time to minimize any familiarity handlers may develop with the codes. Next, if the shipment requires any sort of specialist handling or treatment, then the shipping marks should indicate it. This information should also be present on the bill of lading. And then, all cautionary and handling shipping marks must be permanent and very legible. Ensure that the languages and the origin and destinations are the same, and if not, make sure that shipping marks are in both language. Next, it is highly recommended that a stencil is used when creating shipping marks as it increases legibility. Try to avoid materials which are not waterproof.
So, what exactly is dangerous cargo? Dangerous cargo, also known as hazardous cargo, means that the substance, such as flammable solids, liquids, or gases that can harm people, other living organisms, property, and the environment. There are 10 types of dangerous cargo, which are radioactive, flammable, explosive, corrosive, oxidizing, toxic, biohazardous, asphyxiating, which is a non-toxic or minimally toxic gas which reduces the normal oxygen in breathing air. Pathogenic can also be referred as infectious agent or germ. And lastly, allergenic, which also can be called as allergies reaction. The packing group are divided into three groups, which is the first represent the high or great danger, the second represent medium danger, and the third represent the low or minor danger. The packing group can also help you find qualified packages more quickly and determines the degree of protective packaging required. As an example in the picture, you can see that X, Y, and Z will be used to indicate whether the package is appropriate for all three packing groups or just one packing group. There are 9 classifications of dangerous cargo, which the first class is explosive. There are 6 divisions involved in explosive classifications. Division 1.1, explosive with a mass explosion hazard. A mass explosion is one which affects almost the entire load instantaneously. For example, black powder, dynamite, mercury fulminate, desensitized nitroglycerin. An example of black powder is mostly used for lighting flares, fireworks, and rockets. Division 1.2, explosives with a severe projection hazard, which consists of explosives that have a projection hazard but not a mass explosion hazard. For example, hand grenades, fireworks, and flares. Division 1.3, explosives with a fire, which consists of explosives that have a fire hazard and either a minor blast hazard or minor projection hazard, or both but not a mass explosion hazard. For example, sodium bicarbonate, some liquid and solid propellants, and some rocket motors. Division 1.4, minor fire or projection hazard, which consists of explosives that present a minor explosion hazard. For examples, common fireworks, toy caps, empty primed grenades, and some small arms ammunition. For toy caps, it contains a small amount of material that can start a fire when struck and creates a loud noise accompanied by sparks. Division 1.5, an insensitive substance with a mass explosion hazard, consists of very insensitive explosives that have a mass explosion hazard. Examples are type E blasting agents, some type B blasting agents, and very insensitive explosive substances. Blasting agents are any material or mixture consisting of a fuel and oxidizer intended for blasting. Division 1.6, extremely insensitive articles consist of extremely insensitive articles that do not have a mass explosion hazard. Class 2, gases. Gases in Class 2 are divided into 3 divisions. Division 2.1, flammable gas. Gases that start a fire when they came into contact with an electric spark. For examples, hydrogen, acetylene, and propane. Acetylene is a colorless, pungent-smelling hydrocarbon gas which burns with a bright flame used in welding and formerly in lighting. Meanwhile, propane can be found in portable stoves. Division 2.2, non-flammable gases. Gases that are neither flammable nor poisonous. For examples, nitrogen, refrigerants, and other insert gases. Refrigerant is a working fluid used in the refrigeration cycle of air conditioning systems. Division 2.3, poisonous gases. Gases that, if inhaled, can cause death or serious harm to human health. For example, chlorine. Chlorine is an element used in industry and also can be found in some household products such as bleach. Sometimes it is also in the form of a poisonous gas, as can be seen in the photo of chlorine gas bombs that happened in Iraq. The third class, flammable liquids. Flammable liquid can be easily sparked in air at room temperature. The Occupational Safety and Health Administration, OSHA, of the United States defines that a liquid is flammable if it has a flash point at or below 93 degrees Celsius. For example, fuel, paints, solvents, and alcohol. The fourth class, flammable solids. There are 3 divisions divided from the class for reactive materials. Division 4.1, flammable solids. Flammable solids can be easily triggered and when triggered burn so vigorously and persistently as to face a severe transportation hazard. For examples, matches and self-reactive substances. Division 4.2, spontaneously combustible solids. A solid combustible even in small amounts and in the absence of an external electric spark. For example, metal powder. The common use of metal powder include in the making of magnetics and magnetic products. It can also be used in the welding industry for surface coating. Division 4.3 Dangerous when wet. Dangerous when wet materials react with water, releasing flammable hydrogen gas that can spontaneously start a fire. They can be dangerous if inhaled, ingested, or absorbed through skin, and they are extremely damaging to the tissue. An example of it is pure alkali metals.
Hi, so the next classification of dangerous cargo that I would like to explain is Class 5. Class 5 are divided into two divisions. Division 5.1 is oxidizing agents. These class are often reactive materials because of their high oxygen content. They may react with other flammable or combustible materials. Then, the agents supply the oxygen to keep them burning without any help from oxygen in the air, as is the case with normal combustion. The label is yellow with flame and O symbol at the top and the number 5.1 at the bottom. Division 5.2 is organic peroxides. The molecule contains structures containing carbon organic linked by a double oxygen bond, peroxide. They are designed to be reactive for a number of industrial purposes and may consequently be unstable and sometimes explosive. They often have to be maintained under refrigeration to keep them inactive, and then the temperature must be carefully controlled. Because of their reactive nature, they can be very damaging to the human body, particularly the eyes. The label is half yellow and half red with a flame at the top and the number 5.2 at the bottom. Next, Class 6, Toxic and Infectious Substances. Both substances consist of two subdivisions, which 6.1 and 6.2. The toxics range in power from those which kill in minutes, for example the cyanides, to those which would injure but not necessarily kill. The label is white with a skull and crossbones at the top and the number 6 at the bottom. Another highly toxic materials in Division 6.1, which are toxic specifically by inhalation. This label includes a black background behind the skull and crossbones. Division 6.2 goods contain pathogens like microorganisms that cause infectious disease in humans or animals and certain materials that have low toxicity. The second one includes substances such as virus cultures and potentially infectious blood samples. It's a white label with three crescents superimposed on a circle at the top and the number 6 at the bottom. The lower portion of the label must contain information on who to notify in the event of damage or leakage. Moving on to Class 7, radioactive materials, which are divided into three divisions. Radioactive materials are materials containing unstable atoms that change their structure spontaneously in a random fashion over a time period. Ionizing radiation is generally dangerous to the human body, depending on the type of radiation, the dose, and the duration of the exposure. The difference on the label are, the first one is low-level radioactive materials require a white label with the radioactive trefoil at the top and words including radioactive 1. The second one, moderately radioactive materials require a half-white and half-yellow label with the radioactive trefoil at the top and words including radioactive 2. And the last one, highly radioactive materials require a half-white, half-yellow label with the radioactive trefoil at the top and words including radioactive 3 and a transport index on the label. Next will be Class 8, corrosives. The upper portion of the label contains a pictogram indicating that these materials are corrosive to both steel and human skin. Corrosives are described as either acids or alkalis. The label is a unique hazard class that is half white, half black. Commonly transported corrosives are batteries, fire extinguisher charges, flux, and paint. The last one is Class 9. Miscellaneous dangerous goods are substances which during transport present a danger or hazard not covered by other classes. This miscellaneous hazard class includes materials such as dry ice, environmentally hazardous substances, and elevated temperature materials. The label is white with the top half containing black and white stripes. The bottom of the label displays the number 9.